All right, how to solve a system of equations. And this will happen to be quadratic. There's lots of different sets of equations, but here's one method. So let's say you got two equations here like this, these two quadratic equations. I always like substitution, especially where you have y equals. So this is how to do it algebraically. I'll also show it graphically. And so since y equals 2x squared minus 6, that all can be substituted in for the y up there. So we'd have this equation, 2x squared plus x minus 6 equals x squared minus x plus 2. Then, it's a matter of solving these. Since you've got a squared term, we're going to move everything left and put it in descending order. So I'm going to subtract x squared. And I'm going to add this x to this side, and I'm going to subtract this 2. So what you have left with, that's 0, that's 0, that's 0. So 0 equals negative 6 and negative 2 is negative 8. X and x is 2x. 2x squared minus x squared is x squared. And so now you can either factor that, use quadratic formula. I think it factors, pretty sure it does. So we'll go ahead and just factor it. As you know, in most exams they do factor. If it didn't factor, you'd use quadratic formula. Plus minus is a plus minus, and 8 breaks into 4 and 2, and then we'll just check that to make sure it's right. So that would be 4x, and that would be negative 2x, and that is correct. So what we're looking for is what numbers make this 0. So either this side is 0 or this side is 0. So I set both of those equal to 0 and solve them. And so x equals negative 4, because you'd subtract 4 over. Here you'd add 2 to both sides. Or x could be 2. So here are your two values for x. Now that's not the answer. We're not done yet, because we want to know what y is as well. We're essentially, if you graphed both of these equations, we're looking for where that intersect is. And so I'll check that in GeoGebra when I'm done. But you might verify that these two are correct, like plug in a negative 4 here and make sure you get 0. Plug in a 2 here and make sure you get 0, and you do. So to find out what y is, you plug both of those in. So I'm going to have a set of ordered pairs where this meets. One's at negative 4, one's at 2 for next value. Now you just need to find the y value. So I'm going to use the top equation, y equals x squared minus x plus 2. Y equals x squared, is it minus 2 or plus 2? Let me look. Plus 2. And plug in the negative 4. So y equals negative 4 squared minus a negative 4 plus 2 is 16 plus 4 plus 2. And then, so y in this case, if x is negative 4, we know y is 22. So negative 4 and 22. And then the other place, now you plug in the 2, so y equals 2 squared minus 2 plus 2. Well, that would give you 4. So those should be, there's your answer. Those should be the intersection points. And I'm just going to pull up GeoGebra and double check that. Whoop, there's my elliptical banana. Let's hide my elliptical banana. I don't want to. Forgot I was working on that. The curve on a banana is an ellipse. Kind of cool. Let me just, never mind here. Let me file, new, don't save. Okay, so I'm going to go ahead and graph this thing. And so we have two equations. One is x squared minus x plus 2. So let me type that in. Y equals x squared minus x plus 2. So there's that one. And then your top equation, or bottom equation, 2x squared plus x minus 6. forgotten what it is. Y equals 2x squared plus x minus 6. Okay. And there you go. And we'll go ahead and intersect those two objects to find out where they meet. And they meet here at A, which is 2, 4, and they meet at negative 4, 22. And so if you want to zoom out to see where that's at, there it is. And zoom in. So there's what's happening graphically, and there's what's happening algebraically. So hope this helps. See you next time, and good luck.